With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let's start the question. The question says that a uniform sphere of mass m and radius r is placed on a rough horizontal surface. The sphere stuck horizontally at height h from the floor match the following. So there are multiple options, so we have to match the following results. So before doing that, let's try to analyze what is happening with the given sphere. So if I'm looking at what's happening with the given sphere, at some height h, there is a force applied along this direction, right? So if this is the center of mass, this will be r, and this distance will now be r minus h, right? So that's going to be the r minus h part. So now if you're talking about the sphere which is rolling, if it undergoes pure rolling, then the torque is provided by F into r minus h or h minus r, whatever. So we'll make it as h minus r only. So this can be written as h minus r. So torque will be provided by this. Now we know that if it is also undergoing pure rolling, then V should be equal to r omega. Now what will happen if I am applying force on the top of it, that is when h is exactly equal to 2 times r, then it will be F into r, right? So what will happen in that case? When h is equal to r, that is along the center of mass, if you are applying the force, then the center of mass will be brought in linear motion. There is no torque produced above the center of mass, and hence the body will simply continue in translational motion. So one thing is definite. If h is equal to r, the force passes through the center of mass, and torque about center of mass, that is tau about center of mass, will be 0. Therefore, only translational motion will be seen. So according to this, if h is equal to r, then the sphere has only translational motion, and the loss in energy is due to the friction because it is a rough surface. So from this we will be getting one option correct, that is B is marked with option 4. Now let's say somehow we are going to apply force at h is equal to r by 2 somewhere here. So if I am applying force at h equal to r by 2, the velocity gained by the particle here will be along this direction, right? So if you are talking about the angular impulse here, which is, so at h is equal to r by 2, the angular impulse j is nothing but r cross p. It is of the form of r cross p. So if I am looking at r cross p, I will be moving from r to momentum. The momentum is of the center of mass is in this direction, so I'll have to move it. That means it is gaining momentum in anti-clockwise direction. So the sphere will rotate in the anti-clockwise direction when h is equal to r by 2. That we are sure. Now if it is undergoing pure rolling, at what condition will it undergo pure rolling? That is also there. So how will I get to know that it is undergoing pure rolling? So for it to undergo pure rolling, if it is undergoing pure rolling, angular momentum should be conserved. That means what will I get? mv into h minus r should be nothing but I into omega. So this is a uniform solid sphere. So this will be mv into h minus r is equal to 2 by 5 mr square into v by r, where omega is written as v by r. mv goes away, 1r goes away. So I am left with h minus r is equal to 2 by 5 r. Bring r to this side, so this will become h is equal to 7 by 5 r. So when h is equal to 7 by 5 r, then what will happen? The sphere will be rolling without slipping. So the sphere will roll without slipping and there is no loss in energy because angular momentum is conserved. No loss in energy. So what can we conclude from this? Your h is equal to 7r by 5. Then sphere rolls without slipping with a constant velocity and no loss of energy. So I got D is associated with 1. So B and D we have come across about A and D, sorry, R by 2. Now I also know what happens with A's h is equal to R by 2. When h is equal to R by 2, what will happen? When h is equal to R by 2, the sphere is still going to spin anti-clockwise, and if there is any loss in energy, it is going to lose its energy through friction. So I get to know A also is associated with 3. Obviously, what is left with? C, which is associated with 2. What does C say? H is equal to 3R by 2. Again, sphere will spin clockwise, loses energy by friction. Now, how will I conclude this? So, to conclude this, what I have to do is that if I am taking the torque about the center of mass with the applied force here, so for this particular case, if I am taking the torque about center of mass, will be equal to F into h minus r. If tau is equal to 0, h is equal to r. We know it. Then the body will only have translational motion, which we have concluded. If tau has to be positive, right? So if tau has to be positive, then h should be greater than r. So if h is greater than 1, tau will be positive and hence it will spin clockwise. And whatever loss in energy is there, that is going to happen with the friction. So this is the conclusion we are coming through. So what all do we understand now? We have when h is equal to r by 2, then the sphere spins anti-clockwise, loses energy by friction. Next, when h is equal to r, the sphere has only translational motion, loses energy by friction. When h is equal to 3r by 2, what will happen? Sphere spins clockwise, loses energy by friction, and h is equal to 7r by 5. Sphere rolls without slipping with a constant velocity and low loss of energy. So this will be the mapping of our answers. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.